Okay, in problem 54, we are using whatever operation they would like us to work with these rational expressions. The first one is a multiplication problem. First thing I do with this multiplication problem is factor anything that can be factored. I can factor the numerator and the denominator. So if you need extra help on factoring, you can come and talk to me some other time, or I have a different video on that. But the numerator factors into x plus 1 times x plus 3. The denominator, if you notice, there's only two terms here. They both contain an x. So I can factor an x out of that, and I have x times x plus 3. And then I have 3x over x plus 1 in the denominator. So with a multiplication problem, whenever you're working with that, I can think of this as being one large fraction bar. And when I have that one big fraction bar, I can multiply everything in the numerator and everything in the denominator. And now I can make my giant ones. So x plus 1 divided by x plus 1, those reduce down to 1. X plus 3 over x plus 3 reduces down to 1. And the x here and the x here also reduce down to a 1. So what I have left is 3 in the numerator, because I have 1 times 1 times 1 times 3. So all I have left is 3. And my denominator are just all 1s. So it's 3 over 1, which just equals 3. So taking a look at the next problem. The next problem is now subtraction. However, I already have a common denominator. So since I already have a common denominator with subtraction, I do not need to find that common denominator. I can just now combine my numerators. So my numerator is y squared minus the other numerator, which is 16, over my common denominator of y plus 4. That can be factored. It is a difference of squares. So that factors into y plus 4 times y minus 4. Again, if you don't recognize that, make your generic rectangle and diamond problem. I have y plus 4 left in the denominator. And I can now make my giant 1 right there. So all I'm left with is y minus 4. So that's what problem B simplifies down to. Problem C is a division problem. So instead of dividing by a fraction, we take the fraction we are dividing by, which is now is this one, and we use its reciprocal. So we flip it around. And once we do that, it becomes a multiplication problem. However, the fraction here on the left, I still can factor. So just like in problem A, where I have x squared plus 3x, I'm going to factor the numerator here very similar to that, x squared plus x. I can factor an x out, so I have x times x plus 1. The denominator, that factors into x minus 5 times x plus 1. Now again, switching this to a multiplication problem, I now have x minus 5 in the numerator and 3x squared in the denominator. Now I can make my giant ones. X plus 1 over x plus 1. X minus 5 over x minus 5. And right here, x squared is the same thing as x times x. So that x will reduce down with one of these, making a giant 1 there. So I make a 1 with one of these, so that exponent actually becomes a 1 now. So now all I have left in the numerator is 1, and the denominator is just 3x. Everything else reduced. And the last problem. We are using addition, so I need to find a common denominator, and once again, just like in problem B, the denominators are common already. So all I need to do is add my numerators. So I have x squared, a negative 6x, and a positive 4x is going to simplify down to a negative 2x. So I just added my numerators together, and my denominator is x squared minus 4x plus 4. Now I want to factor, if I can, my numerator, just like in the previous problems here. I can factor that into x times x minus 2. And the denominator, I can factor that into x minus 2 squared, or x minus 2 times x minus 2. I wrote them separately just so we can see the giant 1 I'm making here, and I can see what's left. So I have x divided by x minus 2.